Hello everyone, welcome back to my channel. So in this video we are going to learn about energy and power signals. Okay, so energy and power signals. So how to classify energy and power signals, and what is the procedure to find the energy and power in a given signal, we are going to see in this video. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. Right, so energy signal, so we'll discuss about the first which type of signals are called as energy and power signal. So a signal is said to be energy signal. A signal is said to be energy signal if its energy is non-zero finite value. Okay, so it should be a finite value and it should not be zero also. Okay, zero is also a finite value, so it should not be zero also. Non-zero finite value, that is 0 less than E less than infinity. So where E represents the energy of the signal, so this is the condition for a energy signal. Okay, so for energy signal, this is important point, for energy signal power is equal to 0. For energy signal power is equal to 0. Okay, so I'll explain you this concept when I deal with the formulae. Okay, second point, a signal is said to be power signal. A signal is said to be power signal if its power is non-zero finite value. Non-zero finite value. Okay, so 0 less than P less than infinity. Same as energy signal. If the power is non-zero finite value, then it is called as power signal. If the energy is non-zero finite value, then it is called as energy signal. Okay, so for power signal, energy is infinite. Energy is infinity. Okay, so energy is equal to infinity. Okay, so these are the definitions of energy and power signal. So if you find the energy of the signal, and if it is a non-zero finite value, then we can say that it is an energy signal. If we find the power of the signal, okay, so if you find the power of the signal and if it is a non-zero finite value, then we can say that it is a power signal. Then how to find the power? So what is the formulas to find the energy and power in a given signal? So energy is equal to limit as t tends to infinity integral minus t to t mod x of t whole square dt. Okay, so this is the formula for energy to find. Okay, so similarly in discrete time, limit as n tends to infinity summation n is equal to minus n to n mod x of n whole square is the formula to find the energy. And to find the power, limit as t tends to infinity 1 by 2t integral minus t to t mod x of t whole square dt. And similarly in discrete time case, limit as n tends to infinity 1 by 2n plus 1 summation n is equal to minus n to n mod x of n whole square. Okay, so these two are the formulas for energy and power in the case of discrete time signals. And these are the formulas to find energy and power signals in the case of continuous time signals. Okay, so using these formulas we can find the energy and power in the given signal. So if you find energy and if it is finite, so if you are asked to find whether it is a given signal is energy or power, just use one of these two equations. Don't use two, but you can use any one of the equations. So suppose if you are finding energy and for the given signal and you have got this as non-zero finite value, then we can say that it is energy signal. And if you have got this energy value as infinity, so sorry, if you got the energy value as 0, if you got the energy value as infinity, non-zero finite value, it is a non-zero finite value, it is energy signal. So if you got it energy as infinity, so if energy is infinity, then it is called as power signal. Okay, so by using any one of the equation, either energy equation or power equation, we can find whether the given signal is energy or power signal. Okay, so next we will see an example. So e power minus 3t into u of t. So find whether the signal is energy or power signal. Okay, so you are given with a signal and you are asked to find whether the given signal is energy or power signal. Okay, so generally this type of questions will be asked. So e power minus 3t into of t. So since it is a continuous time signal, I am taking the energy formula for a continuous time signal, which is given by limit as t tends to infinity, integral minus t to t mod x of t whole square dt. Okay, so e power minus 3t into u of t. We know that u of t is unit step signal, which is given by 1 for t greater than or equal to 0 is equal to 0 for t less than 0. Okay, so for t less than 0, this value becomes 0, and when you multiply 0 with e power minus 3t, then its value is totally becoming 0. So e power minus 3t into u of t, this total signal is defined only for positive values, that is for t greater than or equal to 0. Okay, so that is why it is defined only for positive values. Therefore in this limit, the limit value changes here. Okay, 0 to t we will take, because it is defined only for, this total signal is defined only for positive values. So modulus of e power minus 3t into u of t is 1. Okay, so into 1 it doesn't make any difference. So e power minus 3t whole square dt is equal to limit as t tends to infinity, integral 0 to t e power minus 6t dt. Okay, so limit as t tends to infinity, integral 0 to, if you take the integration, what will happen? E power minus 6t by minus 6, and limits are from 0 to t. So this minus 1 by 6 is a constant, so you can write outside minus 1 by 6 into limit as t tends to infinity into, if you substitute the limits, what will happen? So upper limit, if you substitute, it becomes e power minus 6 into t, capital T, minus this becomes e power 0, so e power 6 into 0 is e power 0, so e power 0 is 1. Okay, so if you substitute the limit here, so this is the only term which contains t, capital T. So if you substitute t, capital T is equal to infinity, because limit as t tends to infinity. So if you substitute, what will it become? E power minus infinity only, minus 1. So we know that e power minus infinity can be written as 1 by e power infinity. 1 by e power infinity is 1 by infinity. 1 by infinity is 0. So this becomes minus 1 by 6 into 0 minus 1. So minus 1 by 6 into 0 minus 1 is 1 by 6 joules. So we have got the energy of the signal is a non-zero, it is not equal to 0, and it is finite, non-zero finite value. Therefore energy is non-zero finite value. Therefore the given signal is energy signal. Okay, so this is how we can find by using the formulas and the concept. So concept is very simple. If energy is non-zero finite value, then it is energy signal. If power is non-zero finite value, then it is a power signal. Okay. So next we'll see some of the important points which are useful to find whether the given signals are energy or power signals. Okay. So in that first point, a signal whose amplitude is constant, up to infinity. Okay, so if it maintains a constant amplitude up to infinity, then that type of signal is a power signal. Okay, so for example, suppose you have A into U of t, where A is the amplitude of the unit step signal. So if you have A into U of t maintains constant amplitude right from 0 to infinity. 0 less than t less than infinity, A into U of t maintains a constant amplitude of A. Okay, 0 to infinity. Okay, suppose if you want to find the power in this, so power is equal to limit as t tends to infinity 1 by 2t. As I have told you, limit changes from 0 to t now. Actually in the formula it is minus t to t, but now it changes from 0 to t because it is an unit step signal. So unit step signal is defined only for positive values. So 0 to t mod x of t, so a square dt, mod x of t whole square. So I write the formula here, limit as t tends to infinity, actual formula is minus t to t by x of t whole square dt. Sorry, 1 by 2t will also be there, 1 by 2t. So this is the formula for power. So I have taken limit as t tends to infinity 1 by 2t. So limit changes because it is an unit step signal. Mod x of t is a square dt. So a square is a constant, you can take out of the integration. So becomes now limit as t tends to infinity a square by 2t integral 0 to t 1 dt. So 1 dt is limit as t tends to infinity a square by 2t. So 1 dt is t and the limits are from 0 to t. So it becomes now limit as t tends to infinity a square by 2t into t. So when you substitute the upper limit, you will get t, and when you substitute the down in the lower limit, you will get 0. So this t and this t gets cancelled. Since there is no t term, its value will become a square by 2. So if you observe, power is a finite value. So when power is finite, then we can say that this is a power signal. Okay, this is a power signal, that is unit step is a power signal. Very important point you have to remember. Unit step signal is a power signal. This is what the inference is. Okay, so remember this, very important point. Next, second is all periodic signals are power signals. All periodic signals are power signals. Okay, so as an example you can take a into some cos omega naught t plus theta. So cos omega naught t plus theta is a periodic signal. We know that. I will discuss about this periodic in the next video. Okay, so t is equal to 2 pi by omega naught. Okay, we have seen that in your intermediate also. So same, t is equal to pi by naught. So it is a time periodic signal. So if you find the power in this, so from the AC analysis also we have seen this is the maximum value. So if you want to find the power, we take the RMS value a by root 2 and we take its square. That becomes the power. So power is equal to a square by 2. Since power is non-zero finite value, therefore this is a power signal. this is a power signal. I'm just telling you the classifications, only classifications of energy and power signals. Okay, so all these concepts you know, but the classification is the only new thing. So if you are given with this, you can say that it is a power signal. So all periodic signals are power signals. Okay. Next, third important point here is power signal. Power signal plus energy signal. If you add a power signal with energy signal, then the resultant is also a power signal only. Okay, so if you add anything, power signal is added with energy signal, then the resultant is power signal only. Why? So in the power signal, so power is finite value, so power is finite value. And for energy signal, what is the power? So for energy signal, power is equal to 0. Yes or no? So for energy signal, power is equal to 0. So finite value plus 0 is also a finite value. So finite value, so power will be finite only. Okay, since power is finite, it becomes now power signal. Okay. And fourth point, a signal whose amplitude increases with increase in time, is neither energy nor power signal. It is neither energy nor power signal. So we can't tell it is either energy or power signal. For example, T into U of t, a ramp signal. Okay, so T into U of t is there. Such type of signal is said to be neither energy nor signal nor power signal. So e power 3t into U of t. Okay, so all these signals are neither energy nor power signal. Okay, so neither energy nor power signal. So that is why it is neither energy nor power signal. Okay, so if you find also, you will get different values. Okay, so it is neither energy nor power signal. Just remember this point. Increases with increase in time, it is neither energy nor power signal. So even if you want, you can find energy in this. So limit as t tends to infinity, integral minus t to t actually. So if you are using u of t, it becomes 0 to t. So because it is u of t multiplied by u of t, x square is t square dt. So limit as t tends to infinity, now it becomes t square is t cube by 3, limits are from 0 to t. So limit as t tends to infinity, this becomes t cube by 3. So limit as t tends to infinity, if you substitute t tends to infinity, it becomes infinity. So energy is infinity. And if you find power in this, limit as t tends to infinity, 1 by 2t integral 0 to t x square, so t square into dt. So limit as t tends to infinity, 1 by 2t into t cube by 3, limits are from 0 to t, t cube by 3, limits are from 0 to t. So it becomes limit as t tends to infinity, 1 by 2t into t cube by 3. If you substitute the upper limit and lower limit, it is obviously 0. So it becomes now t square here. So limit as t tends to infinity, it becomes t square by 3. So if you substitute the limit, it will again becomes infinity. So energy is infinity and power is also infinity. Okay, so both the cases are not satisfied. If energy is if a signal is said to be energy signal, if energy is finite, since it is energy is infinity, we can say that power is it can be a power signal, but power should be finite, at least finite. So here power is also infinity. So it is neither energy energy nor power signal. It is not energy or not a power signal. Okay, so that is why I have told you in simple. So all this doing all this in the exam doesn't make sense. Okay, in the competitive exams, if you solve all this, if you are solving all this, it will consume your time. Okay, so don't do all this, just remember this point: a signal whose amplitude increases with increase in time. So as time increases, the amplitude of t into u of t, that is ramp signal, is increasing. So as this is increasing, so as t increases, the amplitude also increases. So that is why such type of signals are neither energy nor power signal. Okay, so the next important point here is fifth one: all finite duration and finite amplitude. Finite duration and amplitude should also be finite. All finite duration and finite amplitude signals are energy signals. Okay, so they are energy signals. For example, you can take any signal, rectangular signal like this, or unit step signal. Okay, suppose if it is from 0 to 4 with an amplitude of 3. Okay, so it is having finite duration, that is from 0 to 4, and finite amplitude, that is 3 volts. Okay, so amplitude here is 3 volts. Such a signal, if you assume it as x of t, if you find energy in this, so energy is given by limit as t tends to infinity integral minus t to t mod x of t whole square dt. So limit as t tends to infinity, it becomes 0 to t. It becomes 0 to t. So 0 to t is now changed to 0 to 4. Yes or no? Because the signal is defined only in this limits only. Signal is defined only in this limit. So the maximum value of t will also be equal to 4. Okay, so limit 0 to 4, x of t is 9, x of t whole square is 9 dt. Okay, so if you substitute, it will become limit as t tends to infinity, it will be 9 taken out, so it will become 4. It will become 0 to 4 1 dt. So 1 dt is t. So limit as t tends to infinity, 9 into 4, it becomes 36. Okay, so this is the energy present in the signal. Okay, so energy is finite, so it is said to be an energy signal. Okay, so sixth, they may ask you operation on signal to find energy. Okay, suppose there is a signal x of t whose energy is E. There is a signal x of t whose energy is t. Then they may ask you to find the energy in the signal x of at. Okay, so this is very important question. So they may ask you to find the energy in the signal x of at. In that case, the energy is given by E by mod A. Okay, so this is what you have to remember. So if x of t is a signal whose energy is E, then x of at, the signal x of at contains the energy E by mod A. Similarly, if you are given with time shifting E x of t minus t naught, so time shifting does not change the energy of the signal. So even if the signal is time shifted, it contains the same energy. And if you are scaled by amplitude, that is a into x of t, so a into x of t, its energy is given by a square into E, where a is some amplitude scaling. And if you are adding a plus something x of t. Okay, if you are adding this, then it is a, its energy is infinity, it is a power signal. Okay, so because a is a constant, so it is a power signal, and x of t we have taken it as energy signal, and as I have told you, power plus energy signal will be power signal, so its energy is going to be infinity. So if you add a DC, if you add DC to some energy signal, if you add some DC to the energy signal, it becomes a power signal. This is the most important point you have to remember. So if you add some DC to energy signal, the resultant will be a power signal. Okay, so these are the important points regarding operations on signals if you are given with an energy signal. Okay, so the next important last point is regarding discrete time signals. So if the discrete time exponential signal is of this form, x of n is equal to a power n and into u of n, and you are asked to find whether the given signal is energy or power signal, energy or power signal. So based on this value of a, we can say that. Okay, so I'll write the cases here. Case A, if mod a is less than 1, if mod a value is less than 1, then it is an energy signal. It is an energy signal. B, if mod a is equal to 1, then it is a power signal. Then it is a power signal. And C, mod a is greater than 1, then it is neither energy nor power signal. Neither energy nor power signal. Okay, so just remember this classification. So suppose if you are given with x of n is equal to 1 by 2 whole power n into u of n. Okay, so x of n is equal to 1 by 2 whole power n into u of n. Then what is the formula to find energy in the case, because this is a discrete time signal, limit as n tends to infinity, summation n is equal to minus n to n, minus n to n. So this will be 1 by 2 whole square. So the limit now changes. Sorry, I have written, okay, I will write the formula first. Limit as x tends to n, mod x of n whole square. Okay, so limit as n tends to infinity, summation n is equal to 0 to n, because it is multiplied by u of n, x of n whole square. So 1 by 2 whole power n whole square. Okay, so this becomes limit as n tends to infinity, summation n is equal to 0 to n. So this becomes 1 by 4 whole power n. Yes or no? So a power m whole power n can be written as a power n whole power m also. So it becomes 1 by 2 whole square whole to the power of n. So it will be 1 by 4 whole to the power of n. So limit as n tends to infinity. Now what will be this value? So 1 plus 1 by 4, if you expand this series, what you'll get? 1 plus 1 by 4 plus 1 by 4 whole square plus 1 by 4 whole cube plus so on. So this is geometric progression. This is in GP, whose first term is 1 and common ratio is 1 by 4. So sum of this is will be a by 1 minus r, where r is the common ratio. So a is 1, first term is 1 by 1 minus 1 by 4. So it will be 1 by 3 by 4, which is equal to 4 by 3. Okay, so this total term is becoming now 4 by 3. So energy in the given signal, this signal, energy in the x of n is given by limit as n tends to infinity, it is 4 by 3. Since no infinity is there, so its value is equal to 4 by 3 only. 4 by 3 joule. So energy is non-zero finite value. So we can say that the given signal is an energy signal. Okay, so the given signal is energy signal. So this is how we can classify okay, so because here mod A value is less than 1, so mod A value here is 1 by 2, so which is less than 1, so it is energy signal. Okay, so in the competitive exams doing all this is not required, so you can just remember this important point. If you are given of this form, if any signal is given of this form, just see this A value and we can decide whether the given signal is energy signal or power signal. So when mod A is equal to 1, what will be, when mod A is equal to 1, what will be the signal? X of n is equal to U of n, and we have seen U of t is a power signal, and similarly U of n is also a power signal. That's all. So when mod A is equal to 1, then X of n becomes U of n, which is a power signal. Okay, so this is how we can classify the energy and power signals. Okay.